So, we just finished our new app. We're absolutely drowning in bugs. Our release cycles are slower than a sloth on sedatives. QA team is burning out, and then boom, I realize we don't need more people and we don't need more time. What we actually need is a complete testing overhaul. Meet the testing pyramid. So wait, I know what you're thinking. A pyramid scheme? Nope, it's better. So it's a visual model that completely changes how we approach testing. Well, let me break it down for you. First, we have unit tests. These are at the base. Then we have integration tests. These are in the middle. And on top, we have UI tests. Sometimes we call them end-to-end. We always call them end-to-end. So here's the key. The wider the layer, the more tests you should have of that type. Here's how I implemented this in our project. The first one is unit tests. These are at the base. These are the foundation. I made sure that we had a boatload of these. They're fast, reliable, and catch bugs early. I'm talking hundreds, maybe even thousands of these bad boys. So the example would be if we are testing that our calculate total function correctly adds items in a shopping cart. The next one, integration tests. These are in the middle. These tests have different parts of the system work together. Fewer than unit tests, but still a hefty number. Example would be, let's say we are verifying that when an order is placed, it correctly updates both the inventory and the user's order history. So, UI or end-to-end tests, these are at the top. These simulate the actual user behavior. We have the least of these because they're so slow and can be really flaky, but these are crucial for catching real-world issues. Example would be testing the entire checkout process, from adding items to the cart through the payment confirmation. So, let's look at the results. We catch bugs earlier in the development cycle. Unit tests are flagging issues before code even makes it to QA now. Our release cycle sped up. With more confidence in our lower level tests, we could run fewer time-consuming UI tests. Our developers started writing better, more modular code to make it more unit testable. So when bugs slip through to production, we usually pinpoint the issue faster by looking at which level of test failed to catch it. But it wasn't all smooth sailing. Here are some challenges I faced and how I overcame them. So the first one is the resistance from developers, of course. Writing unit tests takes too much time. Solution, I showed them how much time it saved in the long run by reducing debugging time. So the second one is over-reliance on UI tests. But this is how the user experience it, you might hear. This is not actually the case. First, you're not the user, nor your team is. Second, UI or end-to-end tests takes so much time. We need to reduce it. We need to avoid any kind of back and forth between the testers and developers. And this is how unit tests actually help us. They tell the developer that a certain thing doesn't work at the development stage, not at the stage of testing. So the third one, it's test maintenance. As our code base grew, so did our test suite. I had to implement a strategy of regularly reviewing and refactoring our tests to keep them efficient. Here's how you can apply the testing pyramid to your project. First, start with a solid base of unit tests. Aim for about 70% of your coverage. Second, build integration tests for critical path in your system, about 20% of your tests. Third one, top it off with a few key UI/end-to-end tests. This should be the remaining 10%. The fourth one, automate as much as possible. Manual testing should be reserved for exploratory testing and edge cases. Fifth, continuously refine your strategy. The pyramid isn't set in stone, pun intended. Remember, the testing pyramid isn't just about having more lower-level tests. It's about creating a balanced and efficient testing strategy that catches bugs early and often. Since implementing the testing pyramid, our team has gone from dreading releases to deploying with confidence. We're catching bugs earlier, releasing faster, and I no longer wake up in cold sweats dreaming about uncaught null pointer exceptions.